first thing we're going to do for example 4 is we're going to put an X through it. Because we're not going to do this question, we're going to do another one instead. If you actually turn the page to 144, you have more space. So on page 144, you can write this as example 4 instead. Solve for X. And we're going to have an interesting situation where there are square roots on both sides, but one of them isn't isolated. There we go. So what we're going to find in this situation, you want to isolate one of them. Well, one of them is already isolated. So if one of them is already isolated, you're going to square. And when you square, you're going to temporarily feel like you did something absolutely wrong. This is getting too complicated. However, it will work out. But you will still have a square root, and you might have to isolate again and square. So I'll show you what I mean. One of them is isolated. You see this one is isolated. So when I square it, it's going to get rid of the square root. But if I square the other side, that's the whole thing squared. You're going to have to FOIL. So I'm going to write it out. I'm going to actually square this side temporarily. I'll put it in brackets just to hold things together. But this side, when you square something, that means multiply by itself. It would look like this. And we would have to FOIL this times this times this. Oh my goodness. And while you're doing this, you might temporarily feel like, I think I might be doing something wrong, because it seems like it's getting more complicated than it should. But here, this times this, well, that gets rid of the square root. I'll just keep it in brackets to hold things together. 2 times the square root of x minus 5 will be 2x minus 5 inside the square root still. And then the inside is again going to be again that. And then 2 times 2 is plus 4. So, I started with 2 square roots, I squared both sides, and I still have 2 square roots. However, do you notice that the 2 square roots that I still have are actually like terms? I could add them together. So I'm going to 2 of these plus 2 of these will be 4 of those. Does that make sense? And I have some other like terms. So for example, I could put my x's together if I subtracted x on both sides. And I could put my numbers together if I add 5 to both sides and I subtract 4 from both sides. What will I be left with? I moved everything else to the left side. My x's go away completely, and I just get 4. It says isolate again. You see that we have the term isolated. You could make your life easier. You could keep the 4 there and square both sides, but since it is very nice to divide both sides by 4, if you can isolate that square root all by itself, it's probably the best. And now we can square both sides again. Squaring both sides again, this is getting 1. Square root goes away, x minus 5. Add 5 to both sides. And I get x equals 6. Does it actually work? Or is this an extraneous root where nothing works? So, first of all, left side, what is x plus 3? I plug in my 6. I get the square root of 9, which is 3. On the other side, I had square root of x minus 5 plus 2. 6 minus 5 is the square root of 1 plus 2. Square root of 1 is 1. 1 plus 2 is 3. They are identical, so I can go to this one, put a check and a circle around it. I know that it works. Now, in our homework, at the back of this, there is no questions that are exactly like this, probably because they like to connect things to our next unit. So I'm going to show you a question that's connected to to our next unit, and I want you to try it on your own. There's lots of space on page, you can, on the side of 145 or maybe the bottom of page 144. Ooh, I don't want to show you the answer though. Here we go. Here's the question. Kind of gave you away the first step. You're going to square both sides. See how far you get until you get stuck. And when you get stuck, I will introduce what the next unit would help you with. When you squared both sides, did you get to there?
Yeah. I was doing that.
Okay, FOIL it out. And then if you combine all of your like terms, did you get to there? Now at this point I would keep the 2 out in front, because if you bring it to this side, you'll just get a fraction. So now we've isolated the second square root. Because they're like terms, you'd have 2 of them. And we square again. But this time you have to FOIL this side when you square. Now if you got up to here, this technically is as far as you know how to do without the next unit. But if I combine my like terms, I move everything over to one side, because this will be 8x minus 16, and I combine everything over to one side, I would have gotten this.
From last semester with the standard form, that's what it's called.
Oh, yeah.
Okay, yeah. We got x squared minus 24x plus 80 equals 0. Now, the problem is, right now, this is very hard to guess and check answers that work, because you're adding and subtracting a bunch of things. To show you how hard it is to guess and check when you're adding and subtracting, I'm going to put a number in my head. Actually, 2 numbers in my head. I'm going to add them together and get 0. Let me pick the numbers. Okay, 2 numbers in my head. I added them together. I got 0. Start guessing. See if you can
6
get.
and negative 6.
No. You just have to guess one.
Minus 194.
No.
18.
3.
2.
No.
Pi.
No. I had 3.8.
Oh.
I didn't even know we were doing decimals.
Your test point,
Like-
yeah.
How long would it take you to guess that?
At least 2 more.
I'd have to like.
However, last year,
Yeah.
we found a way to write this, or last semester, as multiplying. Right? Do you remember that?
No.
I can write this as multiplying. And if I change, I'm going to give you new numbers. Okay, wait for it. Okay, I've got 2 new numbers. I now multiplied them together. The answer is 0. Can you tell me one of the numbers?
0.
Soccer.
I'm
Super
so
easy.
intelligent.
As soon as you change it to multiplying, one of the numbers has to be 0. The other one was 5.73. Okay? But one of them has to be 0. So I can change this. Oh, I'm changing to this. Do you remember what this is called? What's the English word for changing it from this to this? Factoring.
I know that word.
And if you factor it, you would get those 2, and if this one is 0, x is 4, and if this one is 0, x is 20, but the 20 actually doesn't work.
Are you sure that explanation wasn't